Now let's see a formula of compounds with radicals. Now, what is a radical actually? A radical is a group of atoms joined together in a compound having a common valency. And a radical cannot exist on its own. It always combines with another atom, usually a metal, or sometimes it combines with another radical. But it always combines with something. It doesn't exist on its own. And here you have examples of radicals. So hydroxide radical has formula OH valency 1. Nitrate radical has formula NO3 valency 1. Nitrite NO2 valency 1. So you have to pay attention. So one way I use to remember nitrate and nitrite is that nitrate ends with 8, so it has more carbon. Nitrite ends with ite, so it has less carbon. So this is one thing for you to remember. Again, sulfate has more carbon, so SO4. Sulfite has less carbon, so SO3. And you should remember the valency as well. So ammonium is another radical. Ammonium NH4 valency 1. Now be careful. Ammonia is not a radical. Ammonia is a compound. It has formula NH3. And remember that ammonia has less letters in the name, so it has less hydrogen. Ammonium has more letters in the name, it has more hydrogen. So ammonia is not a radical here. Ammonium is a radical. Sulfate, sulfite, carbonate is CO3, it has valency 2. And phosphate is PO4, it has valency 3. So here you see the list of radicals that you need to know for the IGCSE syllabus. Now, a radical is considered as one unit. So hydroxide or sulfate or carbonate will not exist on their own. They will exist combined with something. For example, you could have sodium hydroxide or magnesium sulfate or zinc carbonate. So zinc carbonate is a compound, but carbonate on its own does not exist. So how do we find formula of compounds with radicals? We will be studying these compounds in more detail, but let's see the formula of these compounds. Let's say you want to find the formula of sodium carbonate. So just like you've been doing in the previous step. So first you'll write the name of the element or the radical present. So you have sodium and you have carbonate. And sodium has valency 1. Carbonate has valency 2. So you cross multiply. So you end up with Na2CO3. So sodium now gets 2 and carbonate gets 1. So Na2CO3. I'm not including any brackets here, but when the radical is going to get a number which is greater than 1, then we will need to include brackets. So let's see the other example, magnesium nitrate. So magnesium nitrate contains magnesium and nitrate. Symbol for magnesium is Mg. Symbol for nitrate is NO3. So I'm getting this from the table. So nitrate here, you see. NO3 valency 1, so NO3 valency 1. Magnesium is in group 2, therefore it has valency 2. Cross multiply, we cannot simplify 2 and 1, so let's cross multiply directly. Magnesium gets 1, so we'll have Mg. You don't write that 1 as a subscript, so Mg NO3. Now there's 2 NO3. So if I just put a 2 here, it becomes NO32, which is wrong. So I need to use brackets to show that NO3 is occurring 2 times, which means that in this molecule here, you will have magnesium, and then you will have NO3, and you will have NO3 that will bond with the magnesium. Okay, so there is one NO3 and a second NO3. This is why you have NO3 twice in brackets. Let's try another example. So aluminium sulfide, the elements present is aluminium and the radical is sulfide. So aluminium is Al, sulfide, when you look in that table, sulfide is SO3, it has valency 2. So sulfide is SO3, it has valency 2. Aluminium, as you know, is in group 3, therefore it will have valency 3. 3 and 2, let me cross multiply. So then the formula will be Al2, there is 2 aluminium, and SO3 in brackets 3 times, because there is 3 SO3. A fourth example, so iron 2 carbonate. Iron has symbol Fe. Carbonate, if you look in the table, carbonate is CO3, valency 2. So carbonate, I will write CO3, it has valency 2. Iron, because you have that Roman numerals here, means that iron has valency 2. 2 and 2 I can simplify, so let me simplify that. So you will have Fe1, but I'm not going to write 1, and CO3 1, but I'm not going to write 1 because it's just number 1. So here you have the formula of iron 2 carbonate. Let's do one last example and then you're going to do the exercises. So let's do for copper 2 hydroxide. Copper has symbol Cu. There's 2 here, so it has valency 2. Hydroxide is OH, and if you look in the table, OH has valency 1, OH valency 1. So I'm going to write that, OH valency 1. I cross multiply, so Cu gets 1, and OH is going to get twice. So OH, but I'm going to use a brackets. I'm going to use a pair of bracket because OH is a radical. So whenever you have a radical and that radical gets a number greater than 1, so you're going to use brackets. So then the formula is CuOH twice, right? So this is for writing a formula of compounds with radicals in them. You are now going to work out these questions in your copybook. Now you're going to use the formula with radicals to fill in this table as well. Now these are acids and the salts that they found. So all hydrochloric acid form chlorides. So here you have the chlorine element, so you have the compound chlorides. Sulfuric acid form sulfates, so you see our radical is coming. Nitric acid form nitrates, so carbonic acid form carbonates. So let's see, so calcium chloride, I think you can get the formula of calcium chloride easily. So then sodium sulfate, so sodium sulfate, let's work this out as an example. So sodium is Na, sulfate is SO4. So sodium has valency 1, SO4 has valency 2. You cross multiply, so Na2SO4. So then you're going to go and fill in Na2SO4. Now when you are filling in the document, the workings, you have to do them in your copybook. And when you're filling in that table, make sure that you're writing the subscript properly. If the subscripts are wrong, you will not score for that formula, right? And it's very important, those going for assessment, that subscripts are written properly. So make sure you fill in that table and that you get the subscripts right. Okay, so thank you.